Hello everyone, I'm Farad from the ECC section, and in today's Tech Talk topic, we're going to talk about a new renewable energy index. Let's talk about fossil fuels. Our supply of fossil fuels is diminishing at an unpredictable rate. Increasing energy consumption and manufacturing demands have led to an excessive reliance on fossil fuels. This leads to rise of carbon emissions accounting for a majority of greenhouse gases in the atmosphere. Let's switch to renewable energy resources, which is the key to sustainable future growth for all the countries, especially for those with a high dependence on coal, oil, and gas. Alternatives such as wind, solar, and hydroelectric power can provide supplementary energy and will eventually serve as a main source in the future. In order to gain insight on how well the countries are using the renewable energy resources in their economies and indexes needed. Till now we don't have any existing data on how the renewable energy index is accessed by the countries based on the adoption of clean energy. Today we are going to talk about how to develop a valid and reliable index of renewable energy production and consumption for all the countries at global level. Let's talk about the methods which are used. Selection of key variables. Several matrices for renewable energy production and consumption were considered for inclusion in the new index. Three variables were selected for calculating the renewable energy index, which is also called as REI. These variables were renewable energy output, renewable energy consumption, and electrical production from renewable sources. These indicators reflect transition towards more sustainable methods for energy generation. So here is the formula which is used to calculate the renewable energy index. The above equation shows the calculation of renewable energy index. In this equation, C is renewable energy consumption as a percentage of total consumption. ERE is the renewable electricity output as a percentage of total electricity output. P is the electricity production from renewable sources excluding hydroelectricity as a percentage of total. N is the number of variables. Certain variables were felt to be not suitable for inclusion. For example, combustible renewables and waste of total energy is focused on biomass and biogas, but also includes industrial and municipal waste. The third method is statistical analysis. The data which we downloaded and screened in Microsoft Excel. Metrics taken were aligned up with the countries. After the data preparation, variables were brought into Jamovi statistical software. Correlation heat maps were developed and refined to identify associates between the metrics. Other visualizations, such as scatter plots, were utilized to analyze the relationship of renewable energy index with other key variables. Even a histogram was used to display the frequency distribution of the index. Let us see the results. Let's first talk about the overall descriptive statistics of the index. There were a total of 142 countries in the index, and in this graph we can see the maximum value was 69.5 and the minimum value is obviously 0 and the mean value is 23.1. The standard deviation was 18.2, indicating a fair spread of values. Here we can see in the figure. Let's talk about the associate with other indicators. After generating a correlation heat map, several associations could be discerned, as in the figure 2. The renewable energy index had a negative mild relationship with the access to electricity. R value is equal to minus 0.38, indicating that countries with lower access to electricity were likely to be using renewable resources. A stronger but negative correlation was observed with carbon dioxide emissions. R is equal to minus 0.59. This showed that countries that were using renewable energy sources had lower CO2 emissions. The final power consumption R is equal to minus 0.49. This indicated that high electricity consumption often relies on non renewable sources such as fossil fuels. Let us see how the countries and regional places are ranked. Countries higher up in the REI rankings have more developed renewable energy infrastructure, as you can see in the table 1. Let's see the top 10 countries in this index. We have Kenya, Iceland, Ethiopia, Congo, Nepal, Zambia, Mozambique, Denmark, Costa Rica. And the ranked countries are Australia, Japan, US, and Russia. Let us discuss what we have learned till now. Investment in renewable energy production continues to rise worldwide. Countries are beginning to implement clean energy and solar energy generation into the systems, and many regions have expressed their willingness to purchase energy that has been sustainably sourced. Countries have begun to implement renewable energy sources to generate power for their national grid. This has to be proven to be effective in improving the economic growth of countries in the long run. It is also environmental friendly, and even economic growth takes place rapidly. Three key metrics were utilized to provide an accurate and valid assessment. A renewable energy index has not been published in the research literature or on general media. Research study looked at factors driving renewable energy production in the countries that began to transition towards sustainable energy generation. In that study, data was analyzed from 1990 to 2014 for 27 transition economies. The study indicated that Kyoto Protocol, reinforcement of competition, and public funding led to an increase in renewable sources within those countries. However, a composite index was not created and only one factor was used for comparison. The importance of country wise and regional analysis was discussed in another study by European institutions. Sustainable technology in the electricity factor was emphasized as well. The REI addresses several gaps in indexes and research in transition to sustainable sources. The combination of variables incorporated into the REI help establish a more balanced view of how the countries are adopting cleaner sources of energy. Single variables such as electricity production from renewable energy sources should not be relied upon solely, as these do not consider other renewable energy generation methods. Such sources include small scale of energy grid generation. This is prevalent in African countries where we have the electricity to the central grid is very low. To balance things out, other variables such as renewable energy output should be integrated into the index. Finally, renewable energy consumption integrates the uptake of these sources in the national context. All the three variables are critical and hence have been integrated into the RTI. Now, the countries are aspiring to attain a high rank on this index, need to align their energy policies to all the three factors. Previous research on attaining high levels of sustainability mainly focus on highest carbon emission countries and what they need to transition to sustainable energy sources. With this approach, the smaller nations, which have already transitioned, are not given much attention. The goal of REI is to shed light on the economies that have performed very well in their adoption of renewable energy. Let us take an example to see what is the goal of RTI. Certain African countries such as Kenya, Ethiopia, Mozambique, and Zambia have lower environmental impact in their energy consumption patterns and thus rank higher on the REI than many European nations. Even our study has some limitations. The number of metrics which are available for analysis were only three indicators on renewable energy from the World Bank. As data for these indicators was not available from most of the recent years, index may not reflect the current status of some countries. Due to long-term trends, the data which appears on the robust in accessing the adoption of sustainable sources for energy production. In our future research, we have to plan to access the effect of renewable energy policies and investments on changes in REI over time so that we can get an appropriate data about it. Let us conclude our topic. Renewable energy sources have a broad range of total system, wide occupational health and safety impacts, but a relatively narrow range of average risk to individual workers. Nearly all of the renewable energy sources studied have greater total system wide impacts than a representative coal fuel cycle, reflecting a greater energy and labor intensity per unit energy developed. However, roughly half of the energy resources have lower average risk to the individual workers. Thank you so much.